Hello. The objective of this film is to discover what the Pythagorean theorem is and how to use it. The Pythagorean theorem was invented by the Greek mathematician and philosopher Pythagoras. That's why it's also known as the Pythagorean Theorem, and if you do searches on the internet, sometimes you might find better luck with stuff saying Pythagoras theorem rather than Pythagorean theorem. The Pythagorean theorem says the area of the square built upon the hypotenuse of a right triangle is equal to the sum of the areas of the squares built upon the remaining sides. The sum of this square, the area of this square, is equal to the sum of the areas of these two squares, where this is the right angle. That's where the proof comes in a Pythagorean theorem. I'm not going to go into proofs. I just wanted to show you the beginning part there where it all came from. All right, Pythagorean theorem. What does it all boil down to? It all boils down to this formula. This statement says a squared plus b squared equals c squared. The sum of these two areas of the squares from there are going to be equal to the sum of the area of that square. So a squared plus b squared equals c squared. What can we do with this? Well, if you're given any two lengths of a right triangle, you can calculate the third length using this formula. That's a very powerful tool, and you're going to find you're going to use it quite often. So let's say you are given this triangle, and you're asked to find the missing length, x. Well, the first thing you need to do is determine what's your A, what's your B, what's your C. The A and B are the legs of the triangle. The legs are the ones that are attached to the 90-degree angle. It doesn't matter which one you call A and which one you call B. The legs are the legs. You can switch the order. However, the hypotenuse, the one opposite of the 90-degree angle, the one that does not touch that 90-degree angle, is going to be the C value. That must be the C. So here, well, I'll use 3 for A, 4 for B, and we know my unknown has to be that x, the C. So plugging into the formula, I'm going to have 3 squared plus 4 squared equals x squared. To solve this, we solve it like any equation involving variables. We simplify first. Here we have 3 squared is 9. 4 squared is 16. The equal sign is still there. X squared is still there. We don't know what it is, so it comes down like that. Then we add these two together. We get 25 equals x squared. Now we have to figure out what x is. We don't want to know what x squared is. We want to know what x is. So we're not quite done. We have to find the square root here, because square root undoes a squared. And as you know, anytime you're trying to move stuff to the other side of the equal sign, the other side of those railroad tracks, you need to do the opposite operation. So the opposite of squaring is the square root. The square root of 25 gives me 5, which is equal to your x. And that is my final answer, so I box or circle that. Here's another example. Now remember, the C has to be the one that is opposite of the 90-degree angle, the one that does not touch the 90-degree angle. So in this particular problem, 13 is our C. We're given one of the legs, but not the other. Well, it looks to me like x is the smaller leg. I'm going to make that my A. Why? I can make it B, it doesn't matter. It's up to you. But I do have to plug in something for B, so I'm going to use a 12 for the B. Plug in the Pythagorean theorem. A becomes x squared. B is 12 squared. C is 13, so you have 13 squared. Then we simplify. 12 squared is 144. X squared stays the same. We don't know what x is. 13 squared is 169. Now this was a little different from the last one because these two numbers are on opposite sides of the equal sign. So I can't add them together. Instead, I'm going to have to do the opposite operation to get this 144 to the other side. I'm going to subtract 144. That gives me, these cancel. I get x squared is equal to 25. And again, I'm not finished because I'm looking for x, not x squared. So I've got to do that square root to get the final answer. X equals 5. Is it always going to work out to be 5? No, it just happens to be these two examples work out that way. The Pythagorean theorem only works for right triangles. So you may be asked to determine whether the three lengths you're given can form a right triangle. So if those three lengths plugged into the Pythagorean theorem have both sides equal, then yes, it can form a right triangle. If both sides are not equal, then no, those three lengths cannot form a right triangle. Let's look at this example. Here we are given 4, 7, and 10. Now, these are given to me in ABC order. That's not always going to be the case. So how do I know which ones to plug them in with? Well, C is always the hypotenuse, which is always the largest length. So 10 is the largest number, it must be the C. Same is true over here, 25 is the largest, it must be the C. So if you're not sure whether they're giving them to you in order, the largest one goes in for C, the other two, doesn't matter which one you plug them in for. So let's plug them in. We got 4 squared plus 7 squared equals 10 squared. Simplify, we get 16 plus 49 equals 100, because a 10 squared is 100. 16 plus 49 gives me 65. Does that equal 100? No, it doesn't. Put a non-equal sign there. If they're not equal to, then the answer here is no, it does not form a right triangle. Over here, let's see if this one works. We have 7 squared plus b squared equals, oops, not b anymore, 24 equals 25 squared. So we have 49 plus 576. You can use a calculator for that. And it's 25 squared is 625. Add these two together, you get 625 is equal to 625. And yes, they are equal, so yes, these three can form a right triangle. Now, in math, in order to learn math, you have to do math. So this is your chance to do these problems. I want you to take a moment, pause the video, try these three problems, and then restart the video. And I'll go over these three shortly. All right, we're back. Let's do this one. Remember we have to have the a squared plus b squared equals c squared. So a and b are going to be the 15 and the 20. How do I know? They're the ones attached to the 90-degree angle. So I'm going to have 15 squared plus 20 squared equals c squared, or x squared I should say, which is going to give me 225 plus 400 equals x squared. Add these two together, I get 625 is equal to x squared. Square root both sides, and x is equal to 25. Notice how I flipped the order there, put the x over here, that's fine. All right, now this one. The c is going to be the 10, so this time they gave you the hypotenuse. So what we have is x squared plus 6 squared equals 10 squared, which means we have x squared plus 36 equals 100. We have to subtract the 36 from both sides, and we get x squared is equal to 64, square root, and we get x is equal to 8. Last one here, and we're given these three lengths, and we're asked to determine if the three lengths form a right triangle. Again, C is going to be the largest one, so it's going to be the 15. So we have 9 squared plus 15 squared equals, oops, sorry, not 15. 9 squared plus 12 squared equals 15 squared. If both sides are equal when I simplify, they will form a right triangle. So I have 81 plus 144, and 15 squared is 225. Add these two together, you'll see you do get 225, which means, yes, this does form a right triangle. Thank you for listening, and I hope you all now know the Pythagorean Theorem upside down backwards.